So let's get started, guys,
Yeah.
for the sake of time, because we got less time and a lot of things to cover. Obviously, as
Okay.
for as for to get started, we will talk about obviously SD-WAN, but before that, I want to give a little bit kind of a story regarding why SD-WAN came into being. Okay, so the very first specific session that we're going to talk about now is what is software-defined WAN. But before that, let's talk about SDN, right? So what is SDN? And everyone, please be on mute, guys. So SDN is basically it's an approach to networking that uses software-based controllers or applications to to communicate with underlying hardware. So until now, we know that in speaking in traditional sense, in traditional networking, essential devices like routers and switches all are vertically integrated. That means the decision making logic like control plane and data plane, everything is bundled together in the single hardware box. So the device have its own brain and logic of forwarding, which is data plane bundled together in a box. Now, because of this rigid integration, to change anything in the network, engineers had to log into thousands of individual devices to be able to configure them. So they would need to then configure them one by one, often using complex vendor-specific command line interfaces. This bundled manual approach has a huge cost, and that cost is speed. Deploying a new service or fundamentally changing anything in the network, it usually takes months. This was entirely due to those slow manual processes and the delay of waiting for hardware vendors to implement and ship entirely new features. Because obviously, if there is any new document have passed in by IEEE, that not necessarily Cisco have those features. So we have to wait those new features to be available or delivered by Cisco. So we have to wait. Furthermore, since the control software was closed, right, vendor proprietary, it effectively trapped the customers with a single vendor hardware and software ecosystem. This was initial thinking. Why lock in with just Cisco? Why can't we just use any device and make it like behave how we want? So this key insight behind software defined networking or SDN was to directly address this problem that I just talked about by decoupling the control plane from data plane. It essentially moved the brain that takes the decision to a centralized controller. So by like that, so in a single device, we had a control plane and data plane. In SDN, we took out the control from all these devices and stored them into a central single device called controller. This centralized control gives us few major advantage. First, the SDN controller basically manages a single global view of the entire network. This replaces the need to check thousands of individual devices configuration. You simply, as an admin, you are going to log into this controller. Basically, by the definition, you should be logging into this application. This application takes the data from this controller and shows you all of those thousands of devices of data in a centralized manner in a single graphical user interface. Secondly, it provides the powerful, it provides you the some kind of interface to program your network. It gives you the power of programmability. Network managers and developers can now they can literally write software applications, right? Think of it like a network operating system. Rick, your camera is on. Think of it like a network operating system that directly program the network's behavior using open APIs. So the first one is it gives you the centralized control. Second, it gives you the power of programmability. Now, because of that, you can literally create your own applications. Now, when I say application, it doesn't have to be the complex softwares. Application could be even a small single script as well. So that's what I'm talking about. Finally, this gives us true flexibility because the underlying network device, the switches and routers, it became the simple high-speed forwarding elements that are now just executing the instructions given to them by the controller. They're just simply following the instructions given to them by the controller, right? So what you're seeing here is a picture of uh, of an SDN architecture. All the physical hardware relies in infrastructure layer. We have a software called controller sitting at the control layer, and we have an application, usually a graphical user interface. That's where our user are going to interact with. So basically, the SDN is the result of years of research, but its most recognized breakthrough and the mechanism that launched the modern movement is the open flow protocol. That's what you were seeing here, the open flow protocol. The concept was uh, primarily pioneered by academics at Stanford University and UC Berkeley, working on research projects aimed at making networks programmable. These guys, I'm not sure if you have seen this guy, the most cited pioneer in the context of modern SDN is Dr. Nick McCammon. This was a professor of electrical engineering and computer science at Stanford University. This guy and a couple of other researchers came together in around 2007 and 8 to provide an open standardized way for the SDN controller. These are the guys who first, back in 2007 and 8, thought, hey, why are we doing things traditionally? Why can't we just think network to be in a different way? What was the impact? The open flow was the first open interface. It was a way which allowed the researchers to write softwares to directly control forwarding tables of commercial network switches. What does that mean? So these guys literally wrote some kind of a software using which they weren't directly talking to the routers or switches, they were talking to this guy, and this controller was talking to the rest of the hardware. So this was the impact, and this was very early of their work that I'm talking about. The organization that McCowan was a key figure in co-founding, which was Open Networking Foundation. They called it ONF. They're still in business right now. Maybe they're working with a lot of research bodies like IETF, Wi-Fi, and they have a lot of open source projects these days. So McCowan was a key figure in co-founding ONF. So we established the power of SDN, right? It's centralized control and programmability. Now let's talk about the specific area where this technology has had its biggest real world impact, the wide area network, leading us to directly to SD-WAN. Software defined wide area network is simply the application of SDN principle to connect geographically different sites that are located in really far away from each other. We simply took the principle of SDN, applied it to this the way we were connecting multiple branches together. This was like the really base model of SD-WAN. Definitely, with each iteration, with each version, we introduced a lot of new features, but this was the main. Its primary goal is to move beyond the traditional rigid MPLS networks and to intelligently direct the traffic across a mix of connections. So people who have actually worked on MPLS, they know how big of a role an MPLS circuit plays in business application. But SD-WAN says you don't have to have MPLS. You can simply have literally anything. Why, not just MPLS, and you can get the same performance. You can use 4G, 5G, VSAT satellites, literally anything you can. And because of this, obviously companies like to save the money. That's why its demand is in boom these days. It uses the central controller, which is discussed, to give us the dynamic application aware network that automatically chooses the best path to send the traffic, not just MPLS. Right now, maybe the situation is like that, that let's say the private WAN is not doing very well. The traffic is, even MPLS network is not doing very well. The WAN router detects that and send the traffic via the other path. Now think of it if you're trying to do it manually, right? This is really tough and requires manual intervention to achieve this. And by the time we get to the router, maybe the problem is gone. The problem is actually gone, and it's possible, excuse me, it's possible that MPLS is good back again, right? So a lot of different vendors jumped into the market with their own version of SD-WAN, but the idea was the same, which is to connect multiple branches, data center, the main region, right? Just like what DMVPN would do with the principle of SDN. It's high, the current market is highly competitive, which is a good sign because competition drives innovation. While many excellent solutions exist, there are a couple of vendor exist. Depends on what is the need of the enterprise. You might want to choose the solution accordingly. First, we have networking security pioneers, companies that have integrated their traditional firewall and networking strengths directly into their SD-WAN offering. Think of companies like Fortinet, Palo Alto Networks. Now, these solutions are ideal if security is the company's highest priority. If you buy the Fortinet firewall, the firewall and security is coming with the SD-WAN feature that is inbuilt inside of them. Second, we have the cloud and automation specialist. These vendors focus heavily on ease of use, a rapid cloud deployment. You might have heard of VMware Velo Cloud, HP's Aruba, Edge Connect, right? So these vendors are there. Ultimately, the best choice depends on what is the requirement of the company. As a global networking leader, Cisco have addressed SD-WAN market by offering two distinct solutions. They acquired Viptela and later named it Catalyst SD-WAN, and they have a Meraki as well. First, we have a Cisco Catalyst SD-WAN. This is their high-end feature-rich offering designed for the largest enterprise customer with complex networking needs. It basically offers a deep customization. You have a lot of features in it. You got application level routing. You not just that, but this supports really highly scalable networks. You have hundreds of different branches in there. Meraki does well, but it was made. This is the solution built for simplicity and ease of use, simply like a plug and play. They offer a cloud first approach where you don't have to do a lot of things manually. So that's where Meraki comes in place. But if you have a scalable network, a really big company's network with a lot of different branches, multi data centers, your first choice would be the Cisco's SD-WAN. Let's discuss from business application perspective. What exactly are the benefits of SD-WAN? SD-WAN is, as I just talked about, SD-WAN is a virtualized WAN. It's kind of architecture that allows businesses to use any combination of transport service, including MPLS, obviously. You have LTE 5G, you got broadband internet service as well. Even if you have a VSAT satellite for the sites that are sitting in the middle of the desert in Africa, you can use satellites. With that, you can have a features of SD-WAN as well. The key difference is that it separates the network hardware from the control mechanism, which is managed centrally and intelligently. But what's the problem with the traditional WAN we have? Let's discuss that. We know that in recent years, businesses have been moving to cloud more rapidly than we are expecting. Obviously, we know that if you're looking at the news, you know that since couple of months the internet is going down. It might be DNS or whatever it might be, but despite all the network outages of AWS, Cloudflare, whatever it is, but still cloud is strong as ever. Think about it. Your ERP system is likely hosted on AWS. Productivity suite we are dependent on is Office 365 is also used over the internet. Company's specific application might be still live in your data center. The traditional wide area network is not simply enough. This leads to a couple of problems we have. What are those? First, from the business application perspective. The first is cost. It increased bandwidth demand from cloud services, forcing companies to constantly upgrade their private WAN circuits, which is prohibitively expensive. Now, if you worked in an organization, you know, if you're trying to increase the bandwidth, how expensive the MPLS is. They have a contract just for a 1 year contract. They charge you almost $1 million just for the. Seems like from a non-network engineer's perspective, it seems like it's just a simple network connection, internet connection that should be charging not more than a couple of $100, even if you're going way beyond with their bandwidth. But MPLS, we know the value of MPLS, and it is very expensive. You can't simply go ahead and change the contract saying we have a new business need now. We need a higher bandwidth. We can't simply do that. Second, we see higher latencies. So when you're moving traffic from remote site, right? We have, let's say this is my DC and this is my site. So when we are trying to move the application from the traffic is moving from site and then it's going to the DC, and from there it's going to the internet. Because of this, the latency is also increasing. That is the second problem. The third problem is the availability. With specifically this design, what happens if the DC goes down? All the site's traffic that is coming to the DC, we have a single point of failure, which is a very dangerous situation. Finally, we have a velocity. We want to deploy something new. It's not as easy as it sounds, because first of all, we have to get the approvals. We have to, submit the change request, attend change meetings, schedule a downtime. Maybe if your day is good, you are lucky, you're without any problem, your changes are accepted. If not, then maybe you need to revert and look at it again. So velocity, it's not easy to just simply the deploying anything new like MPLS circuit is very slow. It's a tedious process that always slows down the deployment of any new remote site. So because of these couple of problems, obviously there were other problems in the traditional WAN, but these are the most business affected problems with the traditional WAN that we are looking at, and we are seeing them being challenged by the new modern cloud-based networks. Let's start with the cost. How the SD-WAN is solving that. We talked about how those increasing bandwidth demands forced expensive MPLS circuit upgrades. The SD-WAN solution here is intelligent path selection, and it basically does internet offloads, right? SD-WAN allows you to actively and safely use lower cost broadband internet as well. Because let's say I can send I can create a policy on these devices saying for non-business intensive application, you can send the traffic via the public internet. But for business intensive application that is going to the cloud from this campus, can you use MPLS for that? Now, because of this, it drastically lowers our operational expenses, because you're not sending everything via MPLS, you are choosing what you want to send. Obviously, we can achieve this without SD-WAN as well, but with SD-WAN, it's just a couple of clicks. And not only that, we can also have extra advanced policies where if for MPLS it's not working, you can choose different paths as well. So SD-WAN is smart. One analogy that I learned when I was reading about SD-WAN is the real-time information. Remember this word. That's what special about SD-WAN. So let's say you have a map, and this is your source of this is your source and this is your destination. And let's say you have a path that you're trying to go via, but there is some kind of accident happen, and you have a hard code copy of map. You're looking at a paper. What happens when you're going through this path? Until and unless you are at this point, you don't know if there is an accident. This is what a traditional WAN does. But in SD-WAN, you looked at these issues, okay? You already know because of this real-time information. Like in Google Map, you know, okay, there is 5 kilometers ahead. I'm seeing a lot of red lines. That means there is an accident, there is congestion, there is a lot of traffic. So I don't have to go via that path. I can choose something else, and that's how I can reach to my destination using different path because of this real-time information that I see in the map that there is an accident. Okay, so this is what SD-WAN offers compared to the traditional WAN. We also identified the problem with high latency. This was caused by the inefficient process of moving traffic from remote sites all the way to the data center and then out of the cloud, which severely increased overall route trip times. In SD-WAN solution, we have something called, I'm not sure if you have heard, there are different names to it. I'll simply use direct internet access. The branch don't have to go to the DC and then from exit to the internet. It can simply use something called local breakout. They can here the traffic exists directly. It performs NAT. Internet, the traffic that is actually destined for internet can reach directly to the internet like this. They don't have to go to the DC. By bypassing this corporate data center, this completely eliminates the delay and delivers a massive performance boost to your users. Next, there was this critical problem of the single point of failure. If the DC goes down, then what? Everything goes down. SD-WAN solved this through active active link and dynamic path selection. Unlike traditional setups where a backup link just sits idle, SD-WAN uses all available links, MPLS, broadband, 4G, VSAT satellites, LTE, all of them simultaneously. If one link is failing, traffic is instantly and automatically moved to the other with no manual intervention. You can also, there are features like co-location as well. If DC is down, you can say, hey, you know what? You can send the traffic via this. There is another regional data center. You can send the traffic via that DC as well. So there is less chances of happening this single point of failure as well. Lastly, latency or okay, we've talked about latency. We're talking about velocity. So this problem was happening deploying the private MPLS circuits or any new changes that we're trying to do. It takes months to deliver. Here, the ultimatum is a zero touch provisioning, ZTP, or uh, we also have a different names to it that is coming from Viptela. They're calling it PNP. Excuse me. The ZTP is coming from Cisco, Viptela, and PNP is coming from the Cisco. ZTP is Viptela, PNP is Cisco. With ZTP, you simply ship a new unconfigured AS device to the branch office. You simply just ship it there, and a non-technical person is going to plug it in, and the central orchestrator handles all the configuration. The device is going to come up, is going to contact, let's say, simple. A device comes up, it just going to contact a central authority called a vBond or validator. It's going to authenticate that device and it's going to say, oh, you know what, you're authorized. You can go ahead and connect with the rest of the controllers. So because of this feature, it makes it very unique because I can't tell you we did this site. It sounds funny. We did this huge site where we had two huge 8200 boxes. We onboarded the whole site in just 5 to 6 minutes with ZTP. And there was 8 hours of downtime thinking because of ZTP, we already had everything, and the device simply was shipped to the location. As soon as it came online, it tried to connect to the validator, to this authenticator. It gave it the permission, and the whole site was online. The power of it If you combine ZTP with features like net DevOps, features like uh, programmability, ZTP is actually looks very colorful in there. So we discussed about the four major problems and how we are solving. The cost reduction is there, application performance increased because we are using this something called DIA, direct internet access, local breakout. Network is resilient now because of active link utilization. You're not sending, you don't have simple single point of failure now. You're kind of load balancing the traffic, depends on how your business application needs are. Your operations, if anytime you want to deploy something new, it's super fast. Reason being, zero touch provisioning. So features like these are makes SD-WAN very unique, and Cisco especially, when I'm talking about these features, these benefits, Cisco delivers them with a pinch of salt. Like they're just really good at it. I'm not just saying that Cisco is one of the best company in the world, but they're just good. You know what? They're just good with SD-WAN, especially I'm talking about. So far, so good. Anybody have any questions? Rick, Riyadh, Nateen?
Those are right, no, we are good.
Yes.
I'm good.
Okay, awesome. So let's talk about,
So good.
okay. So let's talk about the Cisco's SD-WAN architecture. Now you need to understand couple of key terminologies before we get into practical stuff. Okay, you should know that what are these key terms, what is called vBond, what is this, because they have rebranded this traditional SD-WAN, right? Before it was Viptela, then they said it's a Cisco SD-WAN. Now they're calling it a Catalyst SD-WAN. Obviously, number one, there is some kind of a monopoly happening there, but apart from that, they did that because all the devices that were sitting at the WAN side, all the branch routers that were connecting to the WAN, these routers were early were from Viptela. They said it's out of service. They are not selling it now. They're not going to support it to these devices now. So all these routers are now your Catalyst devices. That's why they're saying they renamed it, they rebranded it Catalyst SD-WAN. Now let's talk about SD-WAN architecture. The Cisco's Catalyst SD-WAN solution, it is comprised of separate orchestration, management, and control plane, and data plane as well. So we don't have a single controller. Like I gave you an example of principle of SDN, you have a controller that's going to control all the network hardware layer, not like that. So because SD-WAN is a bigger term, the network that we're trying to manage is bigger because what's the word there? The effect, right? If you try to mess up anything just from a one device, here the possibility is that the whole world sites are going to be down. So the effect is huge. So they try to divide the possibility with multiple controllers. Primarily three main controllers. There is a vAnalytics as well. We are not going to talk about that. I'm talking about the main SD-WAN. Let's talk about orchestrational plane. Earlier, we used to call it, there is a controller called vBond. Now we're going to talk about it in a bit, but this is the device where each of the WAN edge router is going to contact first. Every single WAN edge router knows that, okay, this is the IP address of my authenticator, validator. That's the new name that they gave to vBond. After authentication is done, this guy is going to provide the key information that this router needs to communicate with the vManager. Remember I talked about there is a business application, that's where you as an admin going to interact with. Well, this is where you are going to interact. This is the vManager, or now they're calling it simply a manager. This is the web graphical user interface that you are going to see. From here, you also have a third controller. I would say this guy is more than just handling the control plane. Earlier, we used to call it a vSmart. This acts like more like, in a very simplified manner, this guy acts like a route reflector. So it takes the route from one device and send it to everyone. Okay, and we will look at it in a detailed manner for the demo, and for the sake of time, we would like to go ahead. So in a summary, the BPTL SD-WAN, they rebranded it to the Catalyst SD-WAN. The three main musketeers, three main controllers, the vManage was called manager now. vSmart is being called controller now. The vBond is called orchestrator now. The SD-WAN manager is a centralized network management system. It's a software based and it provides a graphical user interface. You simply type the IP address into your computer, assuming that you have the reachability to the manager. It shows you the graphical user interface. And from there, you literally manage the whole SD-WAN. It provides you the single pane of glass to manage everything. Day zero configuration, day one, day two, all the configuration, it packs all the features. If you simply log in, I think 80 to 90% of the configuration you can simply do from this graphical user interface. The rest 10-20%, maybe the site is down, you still gotta log into that device. Things like that can happen. So it's not like fit all in solution. As long as all the devices are reachable, they are not locked in, you can manage everything from this simple graphical user interface. Controller, or before it was called a vSmart, this software-based component is responsible for the centralized control plane of the SD-WAN network. It does so many things. It's simply it's not just a route reflector. It also the replacement of your uh, it's also replacement of your IKE. If two devices are there, two SD-WAN routers, DMVPN, IPsec, right? Two SD-WAN sites are trying to form IPsec tunnel with each other. They don't do that directly. They don't do key exchange. There is IPsec tunnel, but there is no IKE at all. That is something that was mind blowing to me when I learned about it, this fact. So what these guys do, they talk to this controller, they send the keys to their control plane information to form these IPsec tunnel. They send it to the controller. Controller hands it to someone else, other devices, and same thing happens here. And simply they they have each other's these keys, these agreements, and they form the tunnel with each other with the help of this guy. Fascinating. So it not just do a key exchange, it also acts like a route reflector. It helps them. It also pushes the policies. So it also acts like a there is a protocol called OMP, overlay management protocol. Every time that these devices come online, they authenticate themselves. They kind of form these tunnels, TLS or DTLS type of tunnel. We will look at that in upcoming sessions. Over this tunnel, they receive and send the land side routes. Not sure if you know about the front door VRF, but similar kind of concept is applied here. So we have a LAN routes. All the LAN routes are sent to this controller, and the controller is going to send to other branches, to data centers, to all the other sites. And that's how they know if they want to get to certain subnet, they can simply go via that router. I might not have done a justice to the controller or how important this device is, but we will get back to that later in actual classes, especially with all the new feature, high availability, affinities, all those things that Cisco have introduced lately. I think SD-WAN is something that is really fascinating. I'm talking about especially Cisco's SD-WAN, Catalyst SD-WAN. Validator. Now this guy, this is also the role is lightweight, but also without this guy, there is no going to be the second step, because this is where the first step starts. This software-based component it performs the initial authentication of vManage devices. That means all the branch routers, all the data, all the controllers, all of them are going to contact validators. What about manager? What about the vSmart controller? They are also going to talk to these guys because they follow the kind of a structure of public key infrastructure. They need to trust. In order to trust with each other, excuse me, there are two routers. In order to make sure that these guys trust each other, they need to communicate to the vManage. Excuse me, I think I moved ahead. They need to form, in order to build trust with each other, first of all, they reach out to the validator, they retrieves authentication, and once they know that, okay, they all trust a same certificate authority, now they trust each other. We will look at it in the very first thing that we're going to talk about is the controller onboarding. I have a lab spun up already. And lastly, we have the vManage router. This is your infrastructure layer. Now this guy is comes in two forms. It is hardware appliance. Your vManage router comes in a software-based router also. It is going to sit at the physical site, or it also available in the software format, so it can be available, or it also sits at the cloud, and it provides you the secure data plane connectivity among the sites over one or more WAN transports. This guy is responsible for traffic forwarding, security encryption, quality of service, routing protocols. So this is just like a day-to-day router, but controlled by the controllers. And with all the cool features are going to come with it. This is what a normal deployed SD-WAN architecture looks like. So we have a cloud. If you want to connect to the cloud, you have software-based vManage routers. You have a site where you have deployed all the controllers. There are multiple type of designs where uh, there is no specific guide how to deploy the controllers. I mean, in terms of where to deploy the controllers, you can deploy some controllers at on premises. Some you might say you might have deployed them in AWS. There is no fixed guide. Depends on the business needs and how uh, the architects have decided to deploy them. You might have a DC to connect with the data center. As you can see, we also have deployed some vManage routers again. And with these guys, they have formed IP signal via the MPLS. I think this is fascinating to me because we will get to see how all these tunnels are forming, how initial authentication happens, and actually you'll be able to see uh, what do you say, the SD-WAN in action, right? I'm not able to remember the exact phrase for that, but before we get into the practical, let us talk about some key terminologies that you need to remember, right? It's something called site ID that you're seeing. There is a site 1, right? Site 102. There is a site 101. So as you can see, we have some values assigned to a physical location. It's a site ID and it's a unique identification number, and it's a huge number. Starts from 1 to all the way to some 4,294,967,295. So that's a huge number. You can assign these numbers to these sites as well. So they act like an identification number to a specific geographical location, and they play a key role. And the site could be anything. It doesn't have to be a specific DC. It could be DC. It could be a normal branch. It could be a campus, a cloud. It can be anything as long as it's a. The idea behind it is that if two devices are belong to the same site, they should have the same number. So they know that we both are brothers and sitting at the same side. So they don't try to form the IPsec tunnel with each other despite being in the same location. That's why, to avoid that, we keep, if these two devices are in the same geographical location, we make sure to give them the site ID 101. So there is a site ID that we understood. Okay. There is a system IP as well. Okay. As you can see, there is some kind of a IP address assigned to them. Let's say this is equally important as we have router IDs in OSPF. It's a persistent system level IP4 address that uniquely identifies the device. It acts much like a router ID, so it doesn't need to be advertised, nor it have to be known by any underlay devices. They just acts like an identification to the device. So we have one identifier that identifies the site, and we have an identifier. We have an identifier that gives identification to the device itself. Okay. So instead of calling the device name, we are calling it with an IP address. And also when we are giving a system IP to these devices, a loopback interface is also created that acts like a terminating point to these IPsec tunnel. For instance, if I have given a system IP to this device as 10.101.0.2, you will see I'm going here and saying show me the IPsec tunnels. You will see the terminating point to this device. All the IPsec tunnel will be with 10.101.0.2. So it acts like an identification terminating point, and they call it uh, more like a T-lock as well. But T-lock is something else entirely that is coming into the next slides. Organization name is a name that is assigned to the SD-WAN overlay. So it's not just any randomized organization name you can do that. You have to consider things like certificate authority. What is your organizational unit name that you are giving? Because this is really, really important. If you mess up anything in there, and it's not, because inside of a certificate, you're going to have organization name encrypted, and somebody have configured with organization name that is not matching with the certificate, it's not going to install that. It's saying yes, you're trying to install some certificate that doesn't belong to my organization. So it is really essential and important that we consider organization name. We have something called transport locator as well. A T-lock, or transport locator, is going to be an attachment point where vManage router connects to the WAN. What does that mean? In simple plain language, it's going to be your WAN interfaces, as simple as that. But this is going to be, if this device have two WAN interfaces, two WAN circuits, I can say I have two T-locks here. And each T-lock will have some kind of a color. You cannot set, because color is used to identify these WAN circuits. Color is used to identify these WAN circuits. You cannot use the same color twice on a single WAN edge router. So you have a lot of options available: MPLS, biz internet, public internet, bronze, custom colors are available there. You can create your own color. They act like, because color will be, it's kind of an advanced concept. We're going to talk about more in upcoming classes. But color is like, just as of right now, try to understand that it is one of the properties of the WAN edge interface, the interface that connects to the WAN circuit. The OMP, overlay management protocol, it's a routing protocol which has a structure similar to BGP. It also it doesn't, it's, but here in SD-WAN it does more than that. It's not just routing protocol, but is also acts like, it also distributes the security policies as well. So it does more than that. The protocol runs between, especially this protocol runs only between the WAN edge router and the vSmart. Right now it is called as a controller. So it's going to be running in between that. Excuse me, just a moment. We're going to talk more on OMP and vSmart later, because in order to understand it fully and have that full picture of it, you need to see it in practical. But SD-WAN controller here acts like a route reflector. If this side have some routes on the LAN side, as you can see, these are the DTLS and TLS connection. And over that, they have formed the OMP. Just like we have OSP of BGP neighborship, these vManage router try to form the OMP neighborship over these tunnels, and they exchange these OMP routes to the vSmart. What vSmart does? vSmart sends these routes to the other sites, and that's how this router knows. Let's suppose this was x.x route, and this was router 1, site 1, router 1. So because the routes have received from the vSmart, now we know that if I want to get to x.x route, I can simply go to router 1. I have received the route from vSmart, but I know what is my next stop. It's router 1. And they use the IPsec tunnel built between them to send the traffic to each other. That's how the data plane works. So they're just listening to what the control layer is telling them. That's it. Lastly, VPN or VRF, which is everything in the SD-WAN. In SD-WAN overlay, VPN provides segmentation, much like VRF, and forwarding is totally separated here. By default, you're gonna see that you will have two. Here we have VPN 0 and VPN 512. That means, as I said, VPN is equal to, very similar to how VRF is supposed to work. So if you have VPN 0, you're going to have one VRF there. On all the interface, the VPN 0 means this is what we call a transport VPN, transport VRF. If you have two WAN circuits, MPLS and INET, you're going to mention them in the VPN 0. You define VPN 0, and then you be like whatever the interface it is, gigabit 0/0, and you configure everything in that. There is another VPN, management VPN, VPN 512. They're calling it out of band management VPN. All the interfaces that is used for out of band management will be connected here. VPN 512 interfaces, these are not advertised anywhere. Also VPN 0. So what about LAN? We have a specialized VPN. So any VPN that is between 1 to 511 that you define as a user, as an admin, are going to be on the service side VPN. So if you define this VPN, something like simply saying VPN 10, and you said under their interface 3, and you define some route, and the interface is up, quickly there is going to be one VPN 1 route generated and sent to, it's going to be sent to the vSmart. So these are the routes that are going to send to the vSmart, to the controllers. And they are going to send as OMP route. We'll see that in action, how exactly it works out. But a lot of people, when they learn about SD-WAN, they know that we had VHs, no VH devices. This shift, all the configuration that is pushed by the controllers is going to be in the format as you understood before, like VH based configuration. But right now, the vManage routers are iOS XE based. The WebTela OS configuration was very simple. I loved it. But iOS XE made it really hard to process. So all the configuration on the vManage side that we that on the controller that we generate is going to be pushed to IOSXE. IOSXE is going to convert it in a way that is going to work in IOSXE. Okay. So what I'm saying is controllers are going to, even if you push the configuration as a VPN 10 from the controller, IOSXE is going to process it as if it's a VRF because it's an IOSXE, not a VIPTILA. So you will see some differences in the configuration as well. Any questions so far?
So these VPNs, what they transport VPN, these are the default one or what?
VPN 0 is the default one. So this is something that you don't define. VPN 0 is always going to be there. VPN 512 is also going to be there. But service VPNs, these are the ones that you are going to define. You are going to go there because you know now that you want to define this and this VRF on the LAN side. So you are going to go
So
there.
this VPN zero we can't change.
No, we can't change that.
Transport.
It's
Okay.
always
So
going to be the transport VPN. It's reserved.
okay.
Anyone else? Rick? No problem, guys. Let's move on. So try to understand. This is the last slides that we're looking at. Then after this, we're going to jump into the practical. So we understood a couple of terminologies that we're going to need to understand. Now let's talk about how does the control plane works, because that's what you need to understand. The control plane, or what we call as the control connections. So whenever these devices come online, whether it's a manager, a validator, controller, these devices need to form the DTLS or TLS type of connections with each other in order to receive information. It can be by default as of this version, it's a DTLS, but they always can be going to the TLS as demand if organization need to configure them. But this is something that they do it automatically. You don't even have to mention. It's just that the very first thing that happens is the vManage router reaches out to validator, to vBond authenticator. This guy already knows the list that it needs to authorize. And once they're done, it reaches out to the vManage router saying, okay, these are the IP addresses to the vManager and controller. And it goes to them and try to form the DTLS and TLS connection. My pen is stuck. Never mind. So the takeaway is the vManage router, the controllers, they all need to form these DTLS connections, okay, with each other in order to process the information. In terms of the controllers, the manager and controller, everyone is trying to form the connection. First of all, try to understand. Everyone is trying to form a connection with the vBond. Connections to the vBond are vBond or validator. Don't get confused if I'm interchanging the concept, the names. Based on the how many CPUs, vCPUs, virtual CPUs, how many cores these controllers have. Only one connection is formed between the vManage and each vSmart. Only one connection. That's why we are seeing only one connection here, as you can see. Also, the with the vBond, it's a different case. The vManager is trying to form. If I have 4 cores on the manager, it's going to form 4 connection with the validator. If controller have two cores, the vSmart have two cores, it's going to form two DTLS tunnels with the validator. On the vManage, it's a little different story. First of all, the vManage router is going to connect the vBond first. It will try to do that with all transport, and it's going to reach out to the vSmart, try to form one DTLS connection with each transport. If one vManage router have, let's say, 4 transport, it will try to form one DTLS tunnel from each transport. It depends on transport here rather than the cores. On the controllers, it depends on the cores, because this is also important when you're trying to consider the SD-WAN deployment. After the onboarding is done, after this authentication is done, the connection is going to be terminated with the vBond. It's going to keep the connections with the vManager, one connection with vManager only. This is going to be vManager, and let's say these are going to be for vSmart. Only one with this guy, and here it's based on the each transport. Little bit confusing, but something that you have to consider and you have to remember if you're trying to deploy the SD-WAN. In terms of theory, guys, that's it. But let's move on to the practical. Riyadh, are you okay? If you have any questions, please do let me know. Okay, awesome. You can give me thumbs up if you can see the screen, guys. So this is going to be the topology that we are going to work with throughout the class. Okay, for the demo section, we're going to specifically talk about our west coast of the topology. This is one of the DC where I am going to deploy the vManage, the vSmart, and the vBond manager, controller, and validator. As you can see, each of them having two interfaces. This is going to be like this. This is going to be the VPN 0 side, and this in the back end, this is going to be my uh, vBond. Excuse me. This is going to be my VPN 512. That's where I'm sitting at, and from here I'll be able to access all of these devices. Let's see, Cisco. So once you log in, the vManager having the Victel OS, they didn't change that. Pretty simple to use. They still run the lot of show run commands. They still have the configuration, uh, global configuration mode. But here we have three distinct different modes. The first one is a system mode. Now this system configuration, here you can set up the host name, like for instance, host name manager. You can set up the organization name. You can set up the vBond. You have to configure the vBond here. Let me show you the example configuration that I've done. So what you're looking at is the configuration that I have done on the manager. So for system configuration, as you can see, I've configured the host name. The system IP I have given as an identification number. This is going to be my site ID 101. I've given it the organization name called CML SD-WAN Lab Tool. There's a big reason why I did that, but this is out of context. This is going to be the vBond IP. Now this vBond IP is going to be the IP address of your validator's VPN 0 interface, this interface. Okay, so that's your system config. Then we have VPN 0. Very easy to follow. Simply VPN 0 I've configured, and you go into the VPN 0 configuration. Under the VPN 0, I have ETH1, as you can see, and this is ETH1 is configured. It's a case sensitive. If you just say E1, it's going to consider something new interface and is going to give you an error when you hit commit, because it's going to take some times. For instance, if I say VPN 0 and they say E1, as you can see, it successfully have taken this configuration. But when I say commit, it still say, I don't know what you're trying to invalid interface. So there is one small problem with this. It doesn't give you the errors right away. So you got to be careful with that. So interface is one. The IP address you provide like this, they don't take subnet mask like this. You simply provide the prefix value. So this is the subnet. Here we have this whole subnet is 101.0.0.0/24. That's the subnet we have, this whole subnet. I'm going to clone it. For the vManager, this IP, it's going to be 201. As you can see, I have given it IP 101.0.0.201. So that's the IP. For the controller, it's for the controller, this is the control configuration. Under the VPN 0, I've given it 202 configuration. That's the IP address. Okay.
So, but VPN 0 is used for the transport. Why we are giving the interface IPs?
But how it's going to communicate without IP address? You don't even these guys.
So
Uh,
it's
yeah, they need to
it,
talk to these guys, authenticate themselves, and push the configuration. That means they are going to receive the configuration, commands, routes, authentication. So communication requires IP address. We have to configure the IP address, no? Right?
but those IP addresses directly connected to the WAN interface, right?
It doesn't have to be connected
Not
by an interface. It depends on design. There are different ways that different companies design their controller deployment.
okay,
But IP address, regardless of whether they are, you have to configure the IP address. Okay.
okay.
So this was the manager configuration. I've shown you the IP address of each one. What is this tunnel interface? We have configured IP address. The tunnel interface basically says that this interface is an IPsec. Not, excuse me, guys. This tunnel is going to be just like when we try to form IPsec tunnel in Cisco routers. So we create a tunnel interface in there. We create a tunnel interface in there. So just like that, we're simply saying this is going to be a kind of tunnel interface using which I'm going to form the TLS or DTLS type of tunnels. So we simply have to do that. So what I did, look at this. Under the configuration, first of all, I have configured the system level configuration. I said that this is the host name I want to use, manager 1001. This is going to be my identification number, system IP. That's going to be the site ID. This is going to be the my organization name, and this is going to be my vBond or validator IP. This is going to be where I want to the authenticate myself. So even the controllers have to authenticate themselves. They need to build the trust with each other. It's possible that because we don't want to just give up the security, right? We have to have some kind of authentication between them. So that's why we are giving the validator or vBond IP address also in the system configuration. And then under the VPN 0, what I'm doing, look at this. I'm going to be adding one interface, which is each one, putting the IP address. Let's do this until this point. But after this point, you have to make sure that there is a sub mode. When you say tunnel interface, you are inside of each one, inside of the tunnel interface of each one. And what happens if I say allow service all and hit commit? Try to understand. Look at this. If I say show running configuration of, show me just the configuration of VPN 0. Try to understand this. I just typed this. There is an implicit access list. Even if you don't configure anything, all the VPN 0 have one implicit access list, and these services are allowed by default, and these services are disallowed by default. Netconf, things like netconf and stump are needed in order to operate the SD-WAN successfully. But I said I don't want to have this headache just for this lab. That's why I'm simply saying all. So when allow service all, this tunnel interface is going to allow all the services because it's hitting at the top. It's very similar to how access list logic works. So it's not going to look at all these things. It doesn't matter what is allowed or not allowed, since allow services all. What does that mean? In simple plain English, manager is going to form tunnels with controller, validator, or all these vManage routers, site 1, site 2, site 3. All of these routers are going to have, all of these routers are going to allow all the services over these tunnels. That's what it means. And for the manageability, I have connected one more interface from the backside. This is going to be my out of band management, because I need to be able to log into these devices. That's why I've configured my local subnet is 192, and I've given it 201 IP address here, as you can see, Ethernet 0. Similarly, we're going to do the same thing. I'm going to configure system configuration, going to configure 202 IP on this side, 202 IP on this side. Look at this. This is going to be vSmart. That's going to be, I'm calling it controller 1000, giving it this system IP. This is going to be the site ID, organization name, and vBond IP. vBond IP should be this gigabit 0/0 VPN 0 IP address. And then under the VPN 0, we are configuring the tunnel interface, allowing all the services, giving IP address. And just so you know, this default route under the VPN 0, I'm putting it. This is 101.0.0.1 is going to be the internet router on this side, gigabit 0/0 IP address. And VPN 512 also on this side, 192.168.1.202. That's the IP address. I've given it my home router's address as a default router for this config. And there you go. Let's go in there. I'm hit commit. After hitting commit, it's going to save the configuration. There you go. Lastly, I'm going to use, for validator to work, you have to hit one last command in there. Everything is same except that the validator doesn't know that it's a validator. What does that mean? Look at this. If I go under system, all the configuration is cool. Okay. Until this point, it's going to be the same config. But I'm going to say everyone had the same command. vBond is this 101.00203. Look at this. 101.00203. Even vManager had the same command. But here you have to say you are the vBond. You have to say you are the validator. That's why you have to add this local command in there. Then it becomes the validator. It takes up that role. Otherwise, it's simply a normal viptilla router. That's all. Just this command makes a big difference in there. And lastly, after the system configuration, VPN 0 and VPN 12, 512 configuration I'm going to put there. Excuse me, I didn't save it. And hit commit. So let's try to ping, keep in mind, we have two VRFs right now, VPN 0 and VPN 512. From the validator, I'm going to ping 192.168.201. I missed out the third octet in here. 192.161.201. Let us check. Excuse me, guys, my bad. This is the 101 subnet. So when I ping 101.00201, I should be getting replies from the manager. Let's try to ping 202. From here, we are trying to ping, we are pinging the controller. Awesome. So we're getting reply. Let's try to ping from this VPN 512 subnet from here, but I'm pinging into the different VRF, VPN 512. So I have to make sure. Otherwise, what happens if I say 192.168.1.201? It is trying to ping into the VPN 0. And if I say show interface, show me the interface of VPN in the table format, I don't see any subnet with this IP address. So you have to make sure when you are pinging, you have to mention the correct VRF. There is a subnet under the VPN 512. So when I'm doing this ping, I'm going to say I want to ping under the VPN 512 with IP address of 192.168.1.201. Awesome. There is connectivity. That means we have the connectivity. Let's try to do the controller. We can ping the controller. Awesome. So far, so good. Now let's try to, as we can see, this manager is connected to the MPLS switch, which is going to this bridge, which is nothing but is going towards the network where I am right now. So I'm simply going to go to 201. You got to make sure that we use HTTPS. That's all. Just accept this warning and proceed. Admin, admin, and admin 123. And voila. As you can see, we are able to see the manager right now. It's going to give me, based on the version, they're showing me all the new features, all the cool features that we have. I'm simply going to say, I agree and don't show me this. I'm going to say skip for now. Couple of warnings for the first time. Cool. So as you can see, this is the dashboard of my controller called manager. Remember, we don't have one controller, we have multiple controllers available. We have vManage, we got vSmart and vBond, whatever name you prefer, manager, validator, or controller. So this is the dashboard. It's showing me I don't have any other controllers because this guy doesn't trust anyone at the moment. We didn't build the authority. So we need to do that first. It's just recognizing itself, even that is showing in the poor health. There is no managed routers, right? So very first thing that we do at this moment is I'm going to go to administration and settings. The vManage is a complex set of multiple services. The graphical service is totally different. Okay, we have configured organization name and everything at the local level, not here. So what we need to do here is first of all, change a couple of settings. First thing, I'm going to set up organization name. Remember what was the organization name we used here? We've configured CML SD-WAN lab tool. We're going to go to that. That sounds a little funny. It's asking for password. Password is admin123. Paste the organization name. I'm going to save it. Second, set up the validator. The IP address 101.00203. That's the IP address. 201, 202. That's the 203. Hope you didn't get confused there. Updating annotation failed for some reason. 3. There you go. So that's what I'm going to put 101.00203. And this is the port number that everyone is going to connect at to the vBond. So I'm going to keep it exactly the same, 1, 2, 3, 4, 6. So we got to make sure if we have a firewall in here, let's say this is a firewall. So we have to allow these ports so that these guys can pass through the firewall and connect to the validator to form the DTLS and TLS connections. I'm going to say save. Validator IP is also done. A couple of things, we have a banner. I'm going to say welcome to SD-WAN demo. Say whatever you're going to say, right? I'm simply going to save and yes. So every time someone logs in, they're going to see this message. You might want to put something like, authorization level message. You're trying to warn someone for unauthorized access, something like that. After this, you have to scroll down and look at the trust and privacy. We have we can configure things like how we are going to authenticate the hardware managed routers. We got to set some mode for controller as well. We have how we're going to configure the software based managed routers. And we have a couple of things like we can also update the root certificate as well. Do you guys know about the root certificate or public key infrastructure? Do you guys know about it? Nitin?
Yes, a root certificate we have. It is having one public server authority where we can download the root server, that
Okay,
root certificate.
right. Awesome. So we need to generate a root certificate, and everyone is going to install this common root certificate.